the best way to collect wired data. Previously, we discussed technologies for extracting that critical wired data from cloud virtual machines using software that captures the traffic from within the virtual machines and analyzes it locally. But there's another way. Cloud product and service providers have been adding mechanisms organic to their systems that capture and filter and forward the raw packet data directly to another device. Initially, this offering began with the hypervisors. VMware vSphere, for example, includes port mirroring. It copies the traffic, encapsulates it in either GRE or VLAN, and forwards it to a NetScout collection device that can perform the session and service analysis and generate intelligence based upon that. KVM provides a similar function, forwarding a copy of the interface traffic over GRE. Of course, this functionality is part of the hypervisor itself. But when we move to a true cloud environment, the hypervisor is unavailable to us. Even in the case of infrastructure as a service, we can see as far as the virtual network interface, where it hands off the traffic to the hypervisor, but we can't actually touch the hypervisor itself because that's the service that the cloud provider owns. However, there may be situations where you're simply unable to install monitoring software inside that virtual machine. Never mind that its processing and memory requirements are exceedingly small. In some environments, there may be technical or political constraints that make such an installation impossible. In one case, a company already had more than a dozen software agents operating on each and every virtual machine, and the company was a little bit reticent to add yet another one. So, in those cases, there's another approach. The cloud service providers have begun adding traffic mirroring to their infrastructure and platform as a service offerings, and it consists of copying the traffic from the hypervisor, which of course we're not allowed to touch, and forwarding that traffic to another device in the cloud. Both AWS and Azure offer this function, and at the time of this recording, both of them are using VXLAN over UDP to forward the traffic. That's important. There are a few important dimensions of this approach that you should understand before embracing it unreservedly. First, whereas the embedded software approach that we discussed earlier sends only that tiny, condensed, smart metadata, the cloud service providers are sending all the traffic. Of course, you can configure some basic filters, but you're forwarding raw packet data, not the lightweight metadata that we discussed before. Second, and this is really important if your systems are running anywhere close to capacity, the traffic that you forward from the source counts against your quota. What does that mean? Cloud service providers often limit the quantity of traffic that a given instance can receive and transmit. In most cases, it varies based upon the processing power of the virtual machine size that you're selecting and the network technology that you're using. But let's, for the sake of argument, take an example where a given virtual machine is allocated 100,000 packets per second in and out. What if you're running at 75K? No problem. You're well within your allotted capacity. But what happens if you then start forwarding that traffic to another device? Even though the hypervisor is forwarding the traffic, not your virtual machine, that additional forwarded traffic counts against your quota. You went from 75K, and all was well, to 150K, and now you've exceeded your quota. What happens? Well, the good news is that the service providers usually drop the excess capacity from the forwarded traffic, not from the original source traffic. So that means that your services and your applications continue to operate smoothly. But there's a catch. In this example, you're forwarding 75,000 packets per second. 50K of that, 2/3 of it, the service provider is dropping. Now, you turn your attention to your monitoring device, and what do you see? Requests without responses, responses without requests. Fragments are missing. The sky's falling. On a good day, this is just a false alarm. Your applications are running fine, though it's difficult to know for certain. Someone pulled the fire alarm at school, and although there's no sign of smoke, you still evacuate the building just in case. When the red icons start lighting up your monitoring station, you spring into action even before the first customer call comes in. In time, you discover it was a false alarm. Yay! Then it starts happening regularly, and you find yourself in the boy who cried wolf syndrome and start ignoring the alarms. The point is, you'll want to pay particular attention to how much total traffic that virtual machine is forwarding, because you'll be sending a copy of both ingress and egress traffic, inbound and outbound, and you'll be adding that to the existing traffic that the virtual machine is already sending. And incidentally, when there really is a problem on that source virtual machine, it can be particularly difficult to identify if the monitoring platform is detecting a multitude of decoy issues, and especially if it's missing some of the packets that contain the data about the actual problem. Now, it's not a bad thing to use traffic mirroring. In fact, it's quite elegant. But it's critical that you include traffic mirroring in your sizing exercise and deploy virtual machines with adequate network capacity to accommodate it. One final observation related to traffic mirroring and capacity. We're seeing a constant rise in the number of distributed denial of service, or DDoS, attacks in the cloud. Now, if you're the subject of a DDoS attack, the very last thing that you want to do is to forward a copy of all the traffic back across the network to some other device. You've just become an accomplice. In effect, you've doubled the traffic load that the attacker generated. Congratulations, you've just earned your first black hat. This is one of the reasons that deploying the intelligent software within the virtual machine, rather than using simple traffic forwarding, can be a far better approach. Not only does that software analyze the services and applications, but it also detects the DDoS attacks. And instead of forwarding a copy of all the traffic across the network, across the virtual switch to yet another device, it simply sends the attack warning indicators to the monitoring device. In effect, it alerts the attack, but without exacerbating it. Another important observation about traffic forwarding: VXLAN, which most of the cloud service providers are using for traffic forwarding, runs over UDP, which, as you know, doesn't guarantee in-order delivery, or even delivery for that matter. If you're using traffic forwarding, therefore, you'll do very well to place the source of the traffic and the receiver in the same region. That way, you have a high degree of fidelity in the data stream. The packets will nearly always arrive and in order. One more minor detail, but this is important for discussions with upper management when you're negotiating for a particular solution. It's possible that if your packet rate is very high and the intervals between successive packets very low, it's possible that a very small amount of jitter in the network could deliver some of the packets out of order. The one in front gets delayed just a bit, and the one behind it overtakes it and arrives first. Not to worry. Now, this is a bit technical, but stay with me because it's very important. The critical requirement is that the packets for a given conversation arrive in order. In most cases, successive packets within a conversation are usually far enough apart that the little bit of cloud jitter is far smaller than the time between successive packets within a given conversation, so they nearly always stay in order. If there were reordering, it's between transactions, between conversations. So as an analogy, imagine your conversations are cars on parallel one-lane highways. Even if the cars on one highway overtake and pass those on another highway, the cars in each individual highway stay in order. So if you keep your sources and destinations in the same region, you will have nearly zero packets out of order within any given conversation. So in this section, we've considered using traffic forwarding option that the cloud service providers offer. We looked at how it works, considered its impact on traffic capacity, and discussed locating the sources and destinations within the same region to ensure in-order delivery at the receiver. We also talked about why having the packet acquisition technology inside the virtual machine can be especially beneficial if you're concerned about security. We're looking forward to seeing you in our next section. Happy cloud migration.